Here's what we're going to do. Class is starting now. We're going to finish the workbook examples, and then you're going to get out a piece of paper because the school is short computer paper right now, so I do not have a printout of the homework. So you guys are we're going to be doing it as a class just nice and slowly through the rest of the period, depending on how much time we have left. Okay? And then you'll have the homework for the rest of the night tonight. What was that? You did what? You did the homework? Oh. Stephanie already did it, so. She is. Write the equation of the cubic. So this one, a lot of you guys got done.
Yeah. Oh my God.
Oh. Yeah. We didn't do it completely. All right, guys, what's HK? Let's focus. Back row. And Adrian. Okay. Focus, please. HK is 0.2. Fantastic. That's a good start of it. Now we just need to get our A value or B value if there is any. So I went over 1 and down. Right 1, down 1. Left 1, up 1. That's something. That's a reflection. Yeah. You were going to say the same thing, Dylan? Okay. That is a reflection, right? Normally my cubic looks like that, so therefore this has been reflected. But it's still a 1 over 1, so my A or B, whichever one you want to take it as, is still 1 over 1. So I have y equals negative x minus h, which is 0, cubed, plus 2. Now, x minus 0 is just simply x, so we get y equals negative x cubed plus 2, and that's it.
So that's your answer?
Yep, that'd do it.
Only because it's normal except for flip.
Yep, it's just reflected, but there's no stretch or compression in any way, shape, or form. 4. 4's got a horizontal something going on.
And it's like half. And it's half.
And it's half. Okay. If for those of you listening at home, if you guys heard that, that was just Alexa stretching.
Can you hear that on the mic?
This new mic you probably can.
Okay, I'll listen when I get home.
All right. So here, guys, it's the correct way, so it's not reflected in any way. This one is not reflected. And we're going up 1, but we're only going over, as you guys pointed out, a half.
Yay.
We're only going over a half. So we have a horizontal compression. I want you guys to think about that. Horizontally compressed by a half. So we have a B value. Yes, sir.
For the first one, you're saying it's reflected because it's normal, because it's 1 over 1.
It's reflected because normally it goes to the right and up, but now it went to the right and down. Yeah. Gabriel? You want to say something? You put your hand up and then you put it on your head. Oh, okay. So other than that, guys, what's my HK? 3-1. All right. Bless you. So, yes. Mm-hmm. There we go. So that is our horizontal compression by a half, means a multiply by 2 on the inside.
So if it was by 1/3, then
It'd be 3. And if it was horizontally stretched by 3, it would be 1/3 on the inside. Yes? So whenever we're doing stuff horizontally, right, if we move it to the right, it's a minus. If we move it to the left, it's a plus. If we are compressing it by a half, we are multiplying it by 2. If we are stretching it by 3, we are multiplying it by 1/3. So we always flip it. You flip the fraction, right? So flip this. You could say 2 over 1 because you're taking that and flipping it. Yes.
The 2 would go on the outside.
If it was stretching by 2, then it would be a 1/2 on the inside.
Okay, you would do the
Alrighty. Any questions there? This is why I was willing to talk in the beginning for a few minutes, because I knew we only had like an example. I almost finished the lesson yesterday, but it wasn't close enough that I felt comfortable giving you guys homework. Huh? We're gonna get 5 right now. But we had a couple of students saying, hold on, they were still writing. Doot doot doodaloo. Doot doodaloo. Yeah, it's not a long one.
When I get home, I will look for it.
All right.
And if not, I will text Joni and tell her to send me.
The graph of f of x is x cubed is a reflector across the x-axis. Up 11, 7 left. Oh, this is nothing, guys. This is nothing. Okay? No. I'm gonna write down the answer, Samuel, or I'll have somebody. Go ahead. Super easy. Reflected in the x-axis. 7 left, 11 up. That's it.
And because it's 7 the inside, because that's X.
Yeah. Oh.
Wait, no. 6 is the same one as 5, isn't it?
Why do you have 18 pages of
Oh, 'cause I didn't close it from yesterday.
Does it close by itself?
If the computer restarts or something, but I have to manually close it. So. Any questions there, guys? Adrian, any questions? How can I literally call your name and you don't turn around? I'll put you up front. I think if your mom was here, she'd say okay to put you up front. Huh? I can't even hear you.
He's gonna fight his mom.
He's a lawyer.
You'd fight her, and then she'd be like, you know what? I'm not going to sign your to be able to play basketball. And no basketball, huh?
I know, yeah.
All right. Yeah. Probably. All right. Graph of f of x equals x cubed is stretched vertically by a factor of 6. 6. Done. 9 to the right. There we go. Done. I mean, compared to matrices and 3 variable 3 equations.
Can we do homework now?
Yeah. Yeah. Why is it what? Oh, it said f of x. If the other one said it too, then I should have put f of x on it. Yeah. 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 Tim, you're still doing that? How?
I want to know, like, you want to get married in, like, a chapel.
I love how you guys just always sit together. That's what they do in 6th period also. All the exchange students sit together.
They need to be one.
Start plotting against them. They're really about to start a world war.
No, they're not. These
They're
ones
like
are too cute to do that.
getting information on his marriage.
Well, a little bit of this one maybe.
Like, this kid's crazy.
What?
It talks about wanting to be a bird all day.
I live down the street from it, so I don't know. I don't know. You're probably playing.
Okay, I wanted to do number 1 together as a class because of the fact that it brings in a lot of concepts that we may have forgotten. Okay? So first of all, it says to graph f of x equals x cubed. Ladies and Alexa, thank you. So, graph f of x equals x cubed. We already know that one. Yes, sir? Okay, I don't know either.
Do you want us to graph it too?
Yeah. Well, I mean, this is your homework, okay?
How many questions did you remember? I like
19? It says on your note page. You don't have it out?
Do you have graph paper?
Yeah, back there.
This is like the only paper I have. Mr. Base, does the graph have to be good?
You can make it evil if you want, but
Can you just like, as long as you know what it looks like, just like, you know what I'm trying to do?
well, yeah. Try to make it as decent as mine.
As decent as
Alright, let's do this. Is yours a
Nice.
decent line?
It's a decent cube. All right. I'm going to ask you guys, I don't know how much it'll be like dentistry and pulling teeth here,
Thank you.
but I'll be asking you guys, how much of my graph paper did you take, Alexa?
I took like 3.
All right.
I took none. Yeah, how many?
They just didn't put the stack up together. They just spread it out.
Okay. So the first part, old phrase, but it's with every function. State the function's domain and range. Now, it didn't say what style we want to use, so we can use interval, or we can use inequality, or we can use set notation. We're in any way. You want set? Let's use set then. Okay. So, the domain. No worries. Tim, I'm literally doing the homework with you guys. So. Sure. I probably will pick up the homework video at whatever number I stop off at.
So actually, do this then.
Yeah. Adrian. Yvonne, you know, you could sit closer too. It's not about proximity, Yvonne. Okay, guys, my domain. Can somebody, first of all, please re-explain to me what domain is? Ooh, I got a few. Oh, Johnny.
Your x value.
Possible x values. Possible x values. So what numbers can I cube? Amanda.
Oh wait, you mean how far you can go?
Yeah.
To infinity and negative.
Yeah, I can cube anything. From negative infinity to infinity, I can cube anything.
So it's going to be infinity.
Infinity is a concept. I can cube infinity, absolutely. You just get a bigger infinity. Okay. So, it's improvable. Non-provable, I should say. Improvable means we can improve it.
We can't prove that there's an infinite amount of numbers.
You cannot. You can no. You can prove. You can prove the non. You can prove the. You can prove that they are infinite in size, yes, but you cannot prove that infinity exists. You can prove that something is infinite in size, but you cannot prove infinite.
Tower or infinity is pretty good.
Well, how could, okay, what's something you could prove that's infinite size?
Yeah. I am. You can prove that. You can prove that the integers are infinite in size.
Wow, well, dang, I thought you were going to hit me with some real world
Oh.
And range, are we also
Uh, so.
in range also?
Right. So the range is also infinite in size because range is what? No, I know what it is, but what does range mean? Your y values, possible y values, output values. Okay? So my range, so I'm going left and right forever because I can cube anything from the far left to the far right. I can cube anything. And then what will those give me? It will give me positive infinities and negative infinities. So my range is also negative infinity to infinity. Well, this is f of x. They didn't use x. I'm going to have to kind of curve up as I go.
So it's just gonna be same thing.
Yeah. Okay. And Gansky wanted us to use set notation as maybe as a reminder or just to be obnoxious. I don't know which. So. It does. All right. Now, can somebody here that hasn't answered remind me what end behavior looks like? End behavior. Gansky, you haven't answered yet if you'd like to answer. No. As x approaches. They always start as x approaches. Remember, I filled this in for you on your quiz. As x approaches negative infinity, what does f of x approach? And as x approaches positive infinity, what does f of x approach? My negative kind of blended into my infinity there. Keep doing it. There we go. Okay. End behavior can always possibly be on a quiz. What do you mean what? All right. So as I go left, it goes down. It is. And you know, a lot of you guys should be saying wait because a lot of people got that wrong on the quiz. As I go left, that's as x approaches negative infinity. What's going on? It's going down. So it's going to negative infinity. As x goes to positive infinity, it goes up. Whoa. What goes up must come down. Is it on the one coming up? The one we just had? No. Oh, I am still off. There we go. That's the best I can get it. All right. Identify the graph's x and y intercepts. Alexa. 0, 0. That's it. Okay. It goes through the x-intercept is 0. And the y-intercept is 0, because it goes through the origin for crying out loud. For crying out loud. All right. The next part of it. Once again, something that some of you got right, some of you got wrong last time I asked these types of questions on the quadratic quiz. Identify where the function is positive and where the function is negative. Now, notice it says identify the intervals. So you need to give me an interval. When is this function positive? Josiah? When x is greater than 0. When x is greater than 0, the function's positive. So I've got my x-axis. Once I pass 0, everything on this side of the x-axis, my function's positive. Right? I'm going to circle it, then I'm going to identify the interval that is positive. It's positive here. That's the entire place is positive. When is that? When x is past 0. When is it negative? On that side. or x is less than 0. All right, let's get somebody other than that trio or Alexa. When is this function, identify the interval, when this function is increasing? Not that trio and not Alexa. Florian.
Is it the same as the negative?
No. Dylan. When is it increasing?
1, 1, right?
1, 1, it's a static point, is not either increasing or decreasing. I need an interval, an x interval in which the function is increasing. Johnny?
I was gonna say like 0 to 1.
From 0 to 1? 0 to 1 it is, but it's increasing even more than that. Jaden? It's increasing even past that. Samuel?
0 to infinity.
Closer, even further than that.
How do you need to further than that?
Sydney? Negative infinity to infinity, it's increasing.
Well, I had like an epiphany.
Remember, you're starting as a little dot on the far left. Okay? The far left is this arrow way down there. So I'm starting at negative infinity. I'm starting way down there. The entire time that I'm moving, I'm going up. So this function is always increasing. It's increasing. I'm going to do this one in interval notation. Okay? This one's increasing from negative infinity all the way to infinity. When's it decreasing? No. Madeline. No. Never. If it's always increasing, when is it decreasing? Never. So,
Nothing can decrease without increasing.
let me speak to Madeline's point. Okay? If I said I'm starting from infinity and going to the left, am I decreasing? Yes, but we're always talking from left to right movements in math. We're always talking about left to right movements. Huh? I assume that they are actually, because math is math across the globe. I'm going to assume that they're still, unfortunately for them, going to have to read it from left to right. Because I have a feeling in Japan, they don't write their number lines like this. I don't think they do that. I think they still start on the left side with those negative numbers. They might. We could look.
This would be so weird if it is backwards versus ours.
When I got stressed because I don't understand it.
No, it's like art because
What if they're never like
and I don't understand. So I was stressing. I was like,
That's not enough for learning.
wait a minute, what is that? Like she came, she was here. Oh, like where do you come from?
I don't know why this is.
They I'm confused. What?
They write it.
You're not supposed to be.
Come from? It's like so I was like, wait, made a fish out of no birds. That was weird.
Yes.
So just I just say it. I don't even know how to put it surname.
Because it would,
I am super confused by this. His name is
the problem is,
there's a number here? I don't know. The problem is it's in Japanese. I got a friend.
no.
I don't know the name.
The problem here is that everything I'm looking at are all just conversions, so therefore they're taking what's already written. And Desmos would do the same thing. They're going to take something that's already there and just change what they are, and they're not going to change the location. So
What is that?
it's this is just no. It's not. There's no accent. It's Ichi Nissan the Yongo Roku Nanahachi Q Ju Niju Sanju Yonku. Okay. Anyhow.
We're on F.
I can't hear, and that annoys me. Yeah. All right. So tell whether the function is even, odd, or neither. Explain. Well, is the function even, odd, neither? Explain. Yes. Yes.
Is infinity an even or an odd?
F of x equals x cubed. Is it even, odd, or neither? Explain. Shh. Gansky, it's odd. Yeah. Why? Well, that it's not. It's not because what it can't do. It's because what it can do. Yes. It only has one exponent, which is an odd number cubed. That's one reason.
Because 3 is odd. Then 3 was odd.
Okay. X cubed, 3 is odd, and it's the only exponent. When you only have odd exponents on a polynomial, the function is odd. But there's one other thing. It has a certain type of symmetry to it that we learned months ago. Do you remember what it is? What is it? No. Origin symmetry. It has origin symmetry. If you guys don't recall what origin symmetry is I can take the object, I can rotate it 180 degrees, and you can't tell that I rotated it at all.
That's what makes it odd.
That's what makes it odd also. So. Okay. Huh? No, this is the only one.
Okay, G.
It does say describe the graph symmetry, which is it has origin symmetry. Patricia. It says x cubed. Odd. It's an odd exponent, and it's the only exponent. That's the word and.
Damn, I'm not. Oh, I'm not calling you. Isn't that Dick's?
Yeah, he left it here first period. I see your hair, Aaron. All right. Shh. Moving forward, guys. We still have lots of time. Let's see how far we get. On, okay. Yeah,
Wait, we still have G.
I did. I said we answered origin symmetry. Focus, Jaden. Focus. Okay, guys. 2 through 5.
Yeah, we did. He said it has origin symmetry.
How was that?
We did it. You guys got to focus. This is where your little side conversations you have, you don't understand how much you lose out on by being so presumptuous as to think you don't have to listen. Okay? Guys, go ahead. Let's say 45 seconds. Get those written really quick. These are going to be, and it's because these are going to take us 3 minutes tops. Yes. No, total. All 4. All 4 problems will take us just a few seconds. You okay? Tim, I can't hold to it being 30 seconds because I don't know how slow you'll write. Martina, do you believe in karma?
Oh my god, this morning I was asking my kids that to myself.
Huh?
Nothing.
You always ask that question to yourself?
No, like in the morning I don't talk to myself. In my head I talk to myself.
I believe you do.
And I was like, oh, I wonder. I was thinking about asking someone, oh, do you believe in karma? That's so weird.
Deja vu.
We had a connection your freshman year especially. We were on point.
Oh yeah.
You know. That's it.
Do you ever get that feeling? Deja vu.
Okay. Was that like Hermione or something? Oh, don't know it. Okay. All right, guys. Shh. Easy stuff. We're gonna start with Adrian. Number 2. What was it? What's the transformation on number 2 here? 4 right. Okay, number 3.
What? That's all we gotta do?
Yep.
Yeah.
Number 3. There's 2 parts to number 3. What is it? Florian?
It's the different, I don't know.
Reflected?
Reflected
Uh-huh.
and 5 down.
Not 5 down.
5 up.
Nope.
5 right.
Nope.
5 left.
Nope. Jaden.
It's over 1 on 5.
Oh, I need the vertically word. Vertically stretched. Vertically stretched by 5. Okay. Aaron, number 4. Yes, you do. Up 2. Or 2 up, whatever I want to say. Okay. All right. Michael, number 5. Horizontally. Hold on. It takes me a while to write that word. Go ahead. Close. Compressed. By? 1/3. Flip it. Just like when we said earlier on the worksheet, when we said it's compressed by a half and that made us put a 2, this has got a 3, so we're compressed by a 1/3. Okay. Yeah.
How would you know if it's stretched or compressed?
If it's a bigger than 1 or less than 1.
So if it's bigger than 1, it's compressed, and if it's less than 1, it's stretched.
Yep.
Only if it's inside or on the outside?
Inside.
Only if
Outside, it's the same thing, but you go with it.
inside.
So if it's bigger, you're not flipping on the inside. On the outside.
I could be like a
No, it's swapped depending on which one you're in, inside or outside. Josiah, did you ask something sarcastic or did you ask an honest question while everybody's talking to me? Oh. No, I'm not pirating it. The district just never got it finished. Okay. All right, 6 through 9, we're doing the same thing, guys. So another fast one. Okay. Yeah. So 40, actually you don't need to write the instructions, so we'll say 30 seconds to write those down. No, I said to write it down. I assumed you were writing the instructions. What?
serious, bro. Please.
The directions, the commands, instructions, what you're supposed to do. What are those called in? What are they called there? He's like, it's a completely different word. It's instructions.
No, Dad.
I know.
But I was looking for instructions.
Oh.
No, but at this.
Oh, okay. I see. Yeah.
Okay, we have big brains.
All right, guys. Left one.
Yeah.
Okay. Next one. Alexa,
Compressed by 1/4.
vertically compressed. Make sure you get that vertically in there.
That's because
and it's outside. If it was less than 1 and inside, it's stretched by 4 over 1. Horizontally stretched, yeah. Okay. Tim, number 8, because you haven't answered anything. I'm giving you an easy one. No. Down 3. It's outside. Tim, because you failed that one, you're doing number 9 also. Blah.
Horizontally compressed by what? By 2 curves.
Close.
By 3 halves.
Stretched.
Stretched.
It's less than 1. And you flip it.
By negative.
Horizontally reflected as well.
Oh, yes. Yeah, I got it.
So horizontal, so we flip it from 2/3 to 3/2. It is a stretch because 2/3 is less than 1. Or you can look at it also, is it a stretch or compression? Flip it first and then say what it is. 3/2 is bigger than 1, so it's a stretch. That's another way you could say it. Okay, and it's horizontally reflected because we have that negative side on the inside. Yeah. It is. On an odd function, if you flip it horizontally or vertically, it'll look the same. All right, identify the transformations and then graph the new reference points.
Write it down, right?
Yeah.
Yeah.
No, you don't have to. You don't have to write the instructions. You don't have to make your homework look like Stephanie's, unless you want to be awesome. If you don't want to be awesome, you don't have to make it look like Stephanie's.
Okay, I don't want to be awesome.
Okay, that's your choice. So, and that made Stephanie do a little dance right now. She's like, okay. You don't have to write the gigantic bold text, guys. You know, you guys do your homework the way you do your homework. Okay, you have to graph it. That's part of the answer. You should probably write the function right above. Josiah? No, we don't have to write that. We're just literally going to write what the 3 new coordinates are. We're going to graph it and write what the 3 new coordinates are. If I leave you guys with, I'm only leaving you guys with like 8 problems at the end of the day at the most here. I might not even finish. I might not even do like a homework video here. Come on. So. That's not going to happen. Mr. Young still does that thing where he only grades you on the quarter, and it resets your grade, and it's weird.
It's very annoying.
And then you guys like don't do a homework assignment like the beginning of the quarter, and all of a sudden you're all failing. Because he resets his grade at the quarter, and then I think he averages your 2 grades to get your semester grade, which I don't like to do because I don't. My second semester, my second quarter, and my first quarter, personally, his might be different. My second quarter and first quarter are not equally graded. So I don't want, if I average them, I'm saying they're equal to each other, and they're not. Okay. So guys, this is horizontally stretched by 3. Horizontally stretched by 3. I haven't moved it left and right or up or down. Are we okay with that? Yeah. So if I haven't moved it left, right, up, or down, I'm just horizontally stretched by 3. It's just going to make it wider. Yeah, instead of going right 1 up 1, it goes right 3 up 1. Left 1 down 1, left 3 down 1. Because if I stretch 0 by 3, it's still 0. It's the origin stayed the same, yeah. Yeah. So 0, 0 stayed 0, 0. -1, -1 became -3, -1. And then finally 1, 1